students, today is another day that God has made. Today we are going to have our tutorials on linear equations. Linear equations. When we say linear equation, what does that mean? You know, we have, if I'm having this to be, let's say, x, or let's say 2x plus y, or 2x plus, let's say, 6 is equal to 10. This is a linear equation. Why? Because the exponent of this power is 1. But if I'm having, let's say, 3x squared plus 2x plus 9 is equal to, let's say, 0. I'm saying this is what? This is linear. But this is what? Quadratic. Okay? Now, when you solve this problem, since the coefficient or the power here, the exponent here is 1, you are going to get solution set of one value for the linear equation. Okay? But if you see a power here that is squared here, then you are expecting 2 values. So anytime you are solving a quadratic equation, you are expecting 2 values of x. Okay? If I'm having, let's say, 4x cubed plus 3x plus 3x squared plus, let's say, 9x plus 2. This is cubic. And because the highest power here is 3, when you solve this, we are going to get 3 values of x. I'm repeating. We are talking about linear equation. You know, at a certain point in time, we shall be dealing with quadratics, but I want to make this clear to you. This is a linear equation because the exponent, the highest exponent is equal to what? Is equal to 1. So when we solve a problem like this, we are going to get either the line is going to be, once it is having one variable, the graph is going to be like, if you plot it, it's going to be either straight line like this, horizontal or vertical. Okay? There is another linear equations. For example, I can have, let's say, x plus y is equal to 4. Okay? In this case, you know, even though it involves x and y, none of them is having power more than 1. Therefore, it is still a linear equation. A linear equation that involves x and y, or 2 variables like that. When you plot it, you plot a graph, you're going to get something like this. But if it is only 1 variable, you are going to get either horizontal or vertical. I hope I've made my point clear. I'm repeating for the last time before we proceed. I'm saying that this is what? Linear. Why is it linear? Even though it involves x and y, none of them, each of them is having exponential power of 1. Therefore, when you solve it, you are going to get x value and y value. In this case, sometimes they will give you a value for x, then it will help you to solve for y, or value for y help you to solve for x. This is also a linear equation. It is having 1 variable. Is that okay? And this is a quadratic equation. Why is it a quadratic equation? A quadratic equation because the highest power here is 2. Therefore, when you solve, you are expecting x values, 2x values. Here, x values, they are supposed to be 2. When you are solving and you are having a cubic power here, where the highest power is 3, you are expecting a true set with values, x values to be what? To be 3. Is that okay? Now, in solving linear equations, there are certain petty things we look at. For example, here, when we read the word problem here, I'll just be writing the question that we solve straight away. When we read the word problems, then we begin to be projecting some of them. You understand? So, for example, if I have 2x plus 8 is equal to 16. I'm starting from the basis. 2x plus 8 is equal to what? 16. What is this? This is a linear equation, right? It's a linear equation. Why? Because the highest exponent, if I say exponent, I'm talking about the highest power here is 1. Therefore, if I'm to solve, I have to group like terms, right? How do you group like terms? This and this, they are common terms. Why? Because this 8 doesn't contain x. This 16 doesn't contain x. 8 doesn't contain x. But this one, there is x attached to it. Therefore, in grouping the like terms, I'll write it this way. 2x is equal to 16. Then, this is plus 8. When it crosses the equality sign, it becomes what? Minus 8. All right? I hope I'm right. So 2x is equal to 16 minus 8. So here I'm going to get 2x is equal to 8. When you subtract 8 from 16, you are going to get 8. So dividing through both sides by 2, here we are going to get x is equal to what? X is equal to 4. So that is the answer for it. Now let's look at variety of them. I hope I'm clear. Now let's look at another example. If I'm having here, that's why I'm telling you that this one, I'm not going to project it the way, but when it reaches the word problem, then I'll be doing certain sort of projection. Let's look at another one. 7x plus 50 is equal to negative 13. Once again, what happens? Here, I'm having my 7x, okay? Negative 13 is here. So the 50 crosses, it also becomes minus. Is that okay? And remember that when you reach algebraic expression, negative 13, negative 50 will give you negative 63. I'm repeating. So here is 7x is equal to negative 63. So in dividing through both sides by 7, x is equal to what? Negative 9. Is that okay? X is equal to negative 9. Okay. Now here, some people may not be able to understand as expected. So let me pause here and give you a brief explanation of how this one is happening. Okay. So that's that. Now, I said that negative 13 minus 50 or negative 13, negative 50. Some people are getting confused about this. What I'm saying is that if the signs are the same, let's say if I have negative 6, negative 2, okay, they are all very negative signs. So you just add the 6 and the 2, and this is a recap of what you call algebraic expressions, the fundamentals, so that it will help us. Negative 6 and negative 2. Both of them are very negative. Therefore, you are going to write you add them, you get what? Your 8. Then the common sign is what? It's negative. You bring it over there. If I'm having negative 7, negative 10, what is it going to be? It's going to be, you just add the negative 7 and then the 10. That will give you what? 17. Then you bring your negative. Now, if I'm having 6 plus 8, what is the answer? Remember that here, there is a plus here. So over here, we add this and this, we got what? 14. The common sign is plus, but normally we don't plus. So if you see something, if you see a number and there is no plus sign against it, then it is a plus. So if I write 14 without bringing the plus, it is a plus. So let's take note of that. But we shall reach a certain point, certain situation where negative and positive will meet. In that regard, I want to emphasize on this because if you don't get this basis, we shall be in a trouble, along the line. If I'm having, let's say, negative 6 plus 2, what is the answer and why? Negative 6, positive 2. Here you could see that negative and positive have met. Therefore, in bringing them together, you have to subtract the smaller number from the greater, then you attach the sign of the greater to it. So over here, what is absolutely 6 is greater than 2, right? So you subtract 2 from 6. I'm repeating. You subtract 2 from 6. Why? Because 2 naturally 2 is less than 6. And that will give me what? If I subtract 2 from 6, I get what? 4. Then I attach the sign of the greater number to the answer. So the greater number, the sign is what? It's negative here. Right? That's why we get negative 4. Okay? So if I'm having, let's say, 10 minus 16, what is the answer? Still, it is positive and negative here. When you subtract, you are going to get 6. And the sign against the greater number is what? Negative. But if I'm having, let's say, 13 minus 10, what is the answer? Remember, here is plus. So here, the greater number here is what? The greater number here is what? Is 10. Okay? So when you subtract, you are going to get what? You are going to get your 3. Okay, you subtract 10 from 13, you get 3. Then here, it is positive. Normally, as I've already indicated, if it is positive, you don't write it. So the moment you see something here and there is nothing attached with it, it means it is positive. I guess I've made my point clearer. So That is the fundamentals of the linear equations. Okay, so now let's look at another example. I'm having 4p plus 19 minus 3p is equal to 29, right? 4p plus 19 minus 3p is equal to 29. So let's try and group the like terms. I'm having 4p minus 3p. Why am I doing that? Because the 4p, it contains p. This one also contains p. And then we are grouping the like terms. That is the numbers which are not bearing the p. You bring them on the other side of the equation. Now, 4p, let's say 4 pence minus 3 pence will give you what? 1 pen. So I can just write it as p is equal to 10 when you subtract. That is your answer. This is linear equations. Okay, let's look at another one. Let's look at another one. Here I'm having 9r plus 5 is equal to 10r plus 1. Once again, what do? Well, I can bring this one here because some people... So I can have 9r minus 10r is equal to 1 minus 5. Is that okay? So here, 9r minus 10r, as we said, it will give you what? Negative r or negative 1r is equal to negative 4. So if I divide through both sides by negative, r is going to be what? 4. I guess I've made my point over there. Sure. Now, let us look at one or two of today. We'll be dealing more with the word problem. So I'm trying to get these ones clearer. Then it will give us way to the word problem. So that is our very major target. Now let's look at another example. This one, it involves brackets. So if I'm having 4 minus 7 into bracket x minus 6 plus 2 into bracket x plus 1 is equal to 8. And we are asked to solve for x. Solve for what? X. So when we say, but when you say find the true set, we have to be very careful. But here it just says solve for x or find the root of x. So I'm going to expand. So here's what? 4 minus 7x. If you multiply negative 7 to x, you get minus 7x. Now, if you multiply negative 7 by negative 6, you are going to get positive 42. So plus 42, I'm repeating. This is negative 7x. This time, this is negative, positive 42. Negative and negative gives you positive, okay? Then, here, what is it? We have 2x plus 2 is equal to 8. So once again, we are going to do a grouping of the like terms. So here, I'm having 2x minus 7x, okay? I can work out this before I send it. So this part, this is what? 46 plus 2 is what? 48. So plus 48 is equal to 8. So I'm going to have 2x minus 7x is equal to 8 minus 48. All right? So here, I'm going to have minus 5x is equal to what? Is equal to minus 40. And dividing through both sides, here is over negative 5. Over negative 5. So x will therefore give us what? Positive 8. But if he asks you, find the truth set, then you would have written it this way. X is like that. X is equal to 8. Then you close it. Make sure you do it this way. Okay? Now, I hope you're getting this one. Look at how I'm expanding these ones and grouping the like terms. Linear equation of this nature, the most important thing, the vital aspect here is that you have to know how to open the bracket, multiplying when there is negative here, turn to positive, that kind of thing. Then you group the like terms, then you solve, divide through both sides. by the coefficient of the number attaching to the variable. Exactly. So here, linear equation, I don't think it will be much a difficulty. Just follow how I'm doing it, and then you can practice it in most of the box, right? Now, let's look at one or two of those I'm having a linear equation like this. Let's see. X over x plus 3 over 4 minus 2x over 5 is equal to 3. Now, before we move on, after solving this, I will pause and then explain something about how to find LCM of numbers. Because sometimes you have to know the LCM. But some people find it difficult to know LCM of certain numbers. But here, I don't think the LCM is so great, so I can just easily find it. So what is the LCM? 4, and I'm talking about the denominators. 4 and 5, these are the denominators. So we want a common number that can, remember this is over 3, over 1. What is the LCM here? The least common multiple over here is what? It's 20. So in solving a problem of this nature, I can even decide to close the bracket here. It's going to be what? 20 into bracket x plus 3 over 4 minus 20, you can put it this way, 2x, sorry, 20 into bracket what? 2x over 5 is equal to 20 times 3. Anytime you put something into bracket like this, okay, it means it's multiplication. Is that okay? It means it is multiplication. So if that's the case, then how do you do it? This one can go into this and we get 5 here. After getting the 5, still x plus 3. I hope you're getting the point. 4 goes into the LCM 5. That's what I've written. Then minus this same 5 goes here. 4, you can say it 4 here. So 4 into bracket what? 2x, okay, is equal to 60. Most of the candidates or the students, they tend to do the multiplication, and then when they reach it, they just leave the 20 there. That is one of the potential errors that they cause. So at this moment, what do? We have to multiply. So we have 5x plus what? 15, right? I'm multiplying. Minus 8x is equal to 60. Let's see how we do our groupings. So here, I'm having 5x here. I'm talking about numbers that are bearing the x. Minus 8x, okay, is equal to 60 minus 15. I hope you are following the steps I'm going through. First, I found the LCM. The LCM is 20, and I multiplied it through by all the various terms. And after doing that, then I have just opened the brackets now. This is what I'm having. The third step is that I'm grouping the like terms. How do you group the like terms? How do you group the like terms? We group the like terms by looking at the terms that are bearing x on one side of the equation, then those that are not bearing the x into another side of the equation. Is that okay? So now, what do you have here? As I've already told you, here becomes what? Negative 3x is equal to what? 45, right? So how do you solve it? We are going to get x is equal to 45 over negative 3. And that will be negative 15. That will be negative what? 15. Now let's solve another linear equation. That one is x plus 10 over 6 plus 4 plus 4 plus 4 is equal to what? 8 minus x plus 4 is equal to 8 minus x. Once again, what is the only LCM or the only denominator here is 6. Therefore, we are multiplying through by the 6. So here becomes 6 into bracket x plus 10 over 6 plus 6 times 4. As I've already indicated, if I write 6 and I bring into bracket like this and I write 4, it is telling it is multiplying. The bracket means it's multiplying. It's equal to 6 into bracket 8 minus x. So that is, it is multiplying that one also. So this one will cancel this, and we have what? X plus 10, okay, plus 6, 4 is what? 24, right? Is equal to, look at the equality sign. 6, 8 is what? 48. So I'm reminding you that those students, you have to make sure that you go through your times. CS1, CS2, 12, CS3, 18, and that kind of thing. Most of you underrate this, and that is actually one of the downfalls of the students. Make sure you do that. Then minus 6x, okay. Then I think at this point too, we can still group the like terms. But here I can say x plus, what is it? 34. X plus 34 is equal to 48 minus 6x. Okay, and in grouping the like terms, I'm going to have what? X plus 6x is equal to 48 minus 34. So here, I'm going to get 7x is equal to, and I'm having 48 minus what? 34. Here is 4, here is 1. So here is 14. So I'll just divide through, and I'll get what? X is equal to 14 over 7. That gives you what? 2. Okay. They are not difficult. This and variety of them. Okay. So, at this juncture, we are moving straight to the, you can be solving more linear equations as you can. I was having one specific linear equation here as a try or something. Let me quickly see if we can look at that. Okay. Then after that, because there are certain equations in which you can see x in the denominator. But I was about to say something. It looks as if I have forgotten. So let me quickly do that. I was saying that I want to remind you about how to find LCM of numbers. Let's say LCM, least common multiple of numbers. So let's say they ask you find LCM of, let's say, 45 and what? And 60. Okay? They ask you to find 45 and 60. It may be a difficulty for some people or to some people. But let's look at the way I'm going to go about it and follow it. I think you'll be very okay about it, okay? Now, first I pick my 45, okay? Now, I'm going to use what you call the tree diagram, okay, or the factor tree. Here, I'm trying to extract the prime numbers here, okay? I think at a certain point in time, I'll remind you about the prime numbers, but this is for SHS, so I strongly believe that you might have covered it. Nevertheless, if you haven't covered it, I will have a time to take you through at the appropriate time. So, the prime numbers, we have 2, 3, 5, 7, okay, 11. Prime numbers are numbers which have only 2 factors. That's the number itself and 1. So, 4 is not a prime number. Why? Because 2 can go into 4, and then 1 can go into 4, and then 4 itself. So, it has more than 2 factors, 2 factors. But 2, 3, one will ask, why is 2 a prime number? 2 is a prime number because only 1 can go into it. We want number in which only 1 can go into it. That's what we are saying. So 45, 2 cannot go into it. So we have 3 and what? 15. Okay. Then, once again, I have 3. Then here is what? 5. So if I'm writing under the 45, I'm going to get 3 squared, okay, times 5. We put it down. I'm repeating. Look at the way I constructed the factor tree. I'll put this one down. Then we are coming to 60. 60, let's start again. Here is what? 2, 30. I've extracted 2. Then 2 can go into this again. And then what? Is it 15? Okay. Then 3 here, 5. So you could see that for 60, what am I going to get? I'm going to get, we have 2 squared times 3. If I say 2 squared, then times what? Times 5. Now, how are we going to get our LCM? We are going to start from 2. 1, 2, 3, and so on and so forth. So the least base you have here is what? Is 2. Right? The least base you have here is 2. So among 2, though even though there is no 2 here, there is 2 here. And even if there were to be 2 here, sometimes you may have 2 to the power 3 and then 2 to the power 2. You have to choose the one with the highest power. So over here, for the side of the 2, we have only 2 and it is 2 squared. So if I'm having, let's say, 2 to the power 4 somewhere, and then another side, 2 to the power 3, then we choose where the 2 to the power 4 and then do it. We want to find LCM of what? 60, 45, and 60. Why are we trying to find the LCM? Sometimes finding the LCM becomes a major challenge. Okay, so we are trying to extract the prime numbers. So here, this is what we've gotten, and so here we have 3 squared times 5. Why is it 3 squared? 3 squared means 3 times 3, then times 5. Then the 60. How do we extract the figures? The 62, we have 2 times, so we have 2 squared, okay, times 3 times 5. Now, what do? We have to look at the bases. What is the highest, the lowest, the minimum base, whether appearing here or here? You could see that over here, we have 2 here. Even though we don't have any 2 here, once we have 2 here, even if we happen to get 2 here, let's say I'm having 2 to the power 3, then 2 to the power 5. Then wherever, irrespective of the position, we are going to select it from that side. Like, let's say it has appeared here and here. Which of them is bearing the highest exponent? It is 2 raised to the power 5, so that's what you choose. But here, coincidentally, we are not having any even 2. The 2 is only 1. So I'll just write 2 squared, right? Then what about 3? You know, we have 3 here and 3 there. But here, we have 3 squared here and then 3 to the power 1 here. Which of them are you going to choose? Choose the one with the highest power. So we have 3 squared, okay? Then after that, do we have 4? We don't have 4, but we have 5. 5 here, 5 here. They are all bearing the same, exponent. So now, whatever we get here, that will give you what? The LCM. So here becomes 4 times 9, which is 36, times 5. And 36 times 5, I think, is going to be 180 or so. So that is the LCM for 60 and then 45. You have to take note of that. It's very, very important. So let's see if I can quickly give you another one. So that when we get that side clear, it will help us a lot because there are a lot of instances that we will be needing that. So let me say that let's say 42 and even 70. Okay, we want to find LCM for this. It may be a difficulty if you don't know that, or if you don't have the flair, the ability to be able to find. So look at how I'm going to do it in a simplified manner. Okay. Now let's start with the 42. 42. What is the LCM? And what is the prime factor here? I think we have 2, and here is what? 21, right? Then can we extract 2 from here again? No. But the next prime factor we can talk about is 3. So I can have 3, and then here is what? 7. So for 42, I'm going to have 2 times 3 times 7. Is that okay? Now let's look at 70. So this is 70. I can have 2 here, 35, right? Okay. Now, 2 cannot go into this. 3 can also not go. But I think 5 can go. So 5 and then what? 7. So once again, 70 also is bearing what? 2 times 5 times 7, right? So if I'm to write the LCM for this, the minimum base here is what? 2 times, we have 3. Even though we have 3, we don't have 3 here. We can still choose, so we have times 3 times, we have 5 here, we don't have 5 here, but I can still write 5, then times 7. So if I multiply, this is what? 6. So 6, 7, 42. 42 times 5. I think it's going to be, is it 210 or so? 42 times 5 is going to be 210. So you have to note that. Now, we are still under linear equations, but I intentionally decided to take you through this. It's very, very important because there are certain key aspects. If you are not able to break there, the whole mathematics becomes a fiasco. It becomes a difficulty. Now, let's look at another interesting one, okay? Then right from there, we shall start the word problem. Now, look at this one. It slightly confuses a lot of learners. So, 8 over 2x plus 12 over x is equal to 8. This one, we are not projecting anything. I'm writing the question straight on the board. So let's look at it and solve as such. When you read the word problem, that's where we begin to be projecting a lot of them. Now look at this carefully. You could see that we are having x within the denominators. Okay? So here, what is the LCM here? That's the point. The LCM is 2x. So I'm going to multiply through by, so here is going to be what? 2x into bracket 8 over 2x plus 2x into bracket 12 over x is equal to 2x times 8. This is what we are having now. So 2x cancels 2x, here becomes 8. Okay? Then here, x cancels this. So plus 24 is equal to 16x. Okay, so working it out, when you add this to this, you're going to get 32 is equal to 16x. And this one is a cool chop, right? Just divide through by the coefficient here. So here is over 16 over 16. So x will subsequently give you what? 2 as your result. I guess I've made my point. That is how it is. Now, so you can be going through a lot of examples that you think you can be working. But in fact, the major challenge in the linear equation is not on these ones. Even though you shouldn't underrate it, it is not here. It is the word problem, how you'll be able to construct it and then trying to, use the key words in it and interpret them to solve the problem. That actually proves that you are really what? Working. So today, I want to take my time and I'm reminding you that you have to subscribe to the Calendar Man TV. Calendar Man TV, subscribe to that. And then so that all the subsequent updates you get. So Calendar Man TV. Try subscribe and then share this to your brothers. Okay, so that you get more of the update. When you go there, you'll be seeing a lot of motivational messages and even date of birth and others. We shall be dealing with a lot over there.